All right, in this video, we're going to try to give you an idea about enthalpy. Enthalpy is a concept where you've got total heat of a system. So we have the total heat of a system is related to temperature. It's going to be related to chemicals. It's going to be related to bonds in the chemical. It's going to be related to pressure, if there's a gas, and volume, also if there's a gas present. So here we've got a reaction where we've got methane and oxygen make carbon dioxide and water. Now, clearly, this reaction is going to have a temperature. It's not happening at absolute zero. All of the chemicals have their own bonds, and there are different chemicals. There's also pressure, because these are all gaseous reactants and products. This isn't a balanced reaction. I'm not going to worry about that in this video. But you can understand that if we are trying to understand that enthalpy is a result of all of these factors, enthalpy is a really tricky concept to wrap your brain around. The good news is that we will never ask you to actually calculate the total enthalpy of something, because there are just far too many variables to worry about. We can't actually measure this, and enthalpy is measured in kilojoules or joules or megajoules, and it has to do with energy. So what we're really talking about when we talk about enthalpy is energy. We have reactants becoming products. In order for this carbon to become this carbon, so my methane's carbon become carbon dioxide's carbon, I have to break these bonds and make these bonds. And in order for my hydrogens to form water, I have to break those bonds and make these bonds. And one of the key concepts in enthalpy is that bond breaking uses energy. And so our reactants, we're using energy to break all of those bonds, and then bond making or creating gives off energy. And it's helpful to think of something like, if I have my pen, the lid is bonded to my pen, it takes energy to take them apart. That's easy to imagine. Breaking bond using energy is an easy concept. But you get the same amount of energy when you make a bond. And that's a harder concept to grasp. It's not hard to remember because it's the opposite. But if you think about magnets, if you're pulling magnets apart, it takes energy. But if you put the magnets together, they will move towards each other automatically. And so this key concept is present. Now, in enthalpy, we have this complex concept that is not really possible to do a calculation. Conveniently, we don't expect you to calculate the total enthalpy. Instead, we're going to be concerned about the change in enthalpy. And the change in enthalpy will be because of some other change. So the change in enthalpy will be equal to the change in chemical energy. And this is going to be a key concept. We can calculate delta, that change in energy, if we use Q equals mc delta T, Q being energy in joules or kilojoules or megajoules, and M is mass of a substance in grams, C is specific heat capacity, so the specific heat capacity of this specific chemical, and its units will be joules per gram degree Celsius, and delta T is change in temperature. And the change in temperature of this specific mass, so whatever that chemical is, which has a specific heat capacity, if we know the change in temperature, which is in degrees Celsius, my degrees Celsius times the mass will leave me with joules, which are the units for my Q. That's going to be our strategy for doing all the enthalpy questions.